All right, so this week we're going to start off by looking at section 4.4, which is on area of a triangle. All right, so we'll come back to this diagram in a little bit, okay, but we're going to use it to solve our first problem. Okay, so in geometry, or maybe in some other classes too, you've used the formula for area of a triangle. Somebody remind me what that formula is? It's the formula for our area of a triangle. 1/2 base times height. Good. All right, so as long as you know the base and the height, this formula works fine. Okay, but you have to know those two things. Okay, if you don't, you can't solve it with that formula. All right, so what we're going to do is look at a triangle where we don't have the height, and we're still going to be able to find the area. Okay, I'm going to show you where the formula comes from, and then once we have the formula, we just use it. Okay, we don't have to show where it comes from every time. Okay, to show where it comes from, I need the diagram up above. Okay, I don't need to label everything. I'm not going to use everything here. Just label AB, the angle between them, which is gamma. And then I'm going to draw in a dotted line, okay, from the vertex perpendicular to B. Okay, any question on that diagram? All right, so let's see if we can come up with a formula for the height. Okay, let's say they gave me A, they gave me gamma, and I want to find the height. I'm going to focus on this triangle that's on the left. Okay, B I'm not going to use right now. B is the length of the entire bottom side. Okay. So I'm just focusing on the left half. What kind of triangle is that on the left? Yeah, it's a right triangle. Okay, and anytime we have a right triangle, we can use right triangle trig. All right, the only thing I got to figure out is the names of these two sides relative to gamma. So my choices are opposite, adjacent, and hypotenuse. Okay, what is H? Is that opposite, adjacent, or hypotenuse?
Opposite.
That's opposite. And what about A, which is across from the 90? That's hypotenuse. Which trig function involves opposite and hypotenuse? Sine. Good. All right, so we have the sine of our angle, gamma, equals, okay, and now write opposite over hypotenuse, or in this case, H over A. Again, H is height here, okay, so don't get that confused. H is height of the triangle. Okay, any question on that equation so far? Okay, now my goal is to get a formula for the height. Okay, so I want to get H by itself. So what would be my last step to get A on the other side? Multiply. Yeah, multiply by A on each side. Perfect. And there is a formula for the height. Okay, now all I'm really going to do is take this, which equals the height, and I'm going to fill it in right there. So I'm still going to keep the 1/2 base part of the formula. I'm just going to change H to A sine gamma. Any questions why I can plug in A sine gamma for H? Because it equals H. Right? And when we do that, we're going to have 1/2 B times A sine gamma. Okay, so that's another formula for finding the area of a triangle if you don't know the height. Okay, technically, it's still finding the height for you. It's kind of hidden in the formula. Okay, that's the height right there. So you're still finding it. We're not thinking about it anymore. We're just going to type that all into the calculator and get a final answer. Right. Now, when I multiply two things together, does the order matter? No. Like if I do 2 times 3 or 3 times 2, it doesn't matter. So what they usually do is they like things in alphabetical order. So they write it as 1/2 AB sine gamma. There's no difference. It's just usually we put it in alphabetical order to remember it. All right, let me draw that triangle we had up above. This side was A, B, C. Okay, I'm just going to label everything. Alpha, beta, and gamma. So look at the first formula and then look at my diagram. It was 1/2 AB sine of gamma. Notice where gamma is compared to A and B. Where is it? Yeah. It's in between them. Yeah, so it's like we have a side, we have an angle, and we have a side. Well, we don't just have to use those 3. We could use those 3. Okay? Or we could use those 3. Okay? As long as you have 2 sides and you have an angle between them, you can write this formula 3 different ways. So could anybody give me the version using those 3? How do you think that would be written? Yeah?
1/2 BC sine beta for alpha.
Sine alpha, yeah. 1/2 BC, 2 sides, times the sine of the angle between them. And what about the last version? Let's see if I can do this. Using the top 3. Yep.
1/2 AC sine beta.
Beta, yep. So what I try to do is I don't memorize all 3. Like, wait, is it the BC with alpha or is it the A and the B with the gamma? I just remember in general, okay, the area of a triangle, it's half the product of 2 sides multiplied by the sine of the angle that's between them. Okay, that's it. Half the product of 2 sides times the sine of the angle between them. Okay, so if you can remember that, you don't even have to know what side A, B, and C are. Multiply 2 sides times 1/2 times the sine of the angle between them. And that's it. So it's a nice shortcut when we don't know the height. Kind of builds finding the height right into the formula. But we're not even thinking about that. Okay, we're just using the formula, and we're going to find the area. Since it's area, make sure you always put the right units. Okay, so if your problem is feet, if that's the length of each side, how do you measure area in feet? What's the units?
Square feet.
Square feet. Okay. Square feet, square inches. If they don't put a label on the problem, you're going to use this. Just put square units, 10 square units, whatever it is. Okay. Anybody need to copy down formulas? All right, so let's sketch this and make sure they gave us the right information. Okay, once you've done a lot of them, you can look at this quick and say, yeah, they did. They gave me side angle side here. All right, but if you're not sure, let's just make a sketch. There's A, there's B, that would be C, and gamma always goes across from C. Side angle side. All right, so anybody think they can set up my formula here? You don't have to do it out, but just tell me, what do I multiply together to get the area? Eddie?
It should be 1/2 8 times 6 sine 30 degrees.
Yep. 1/2 the product of 2 sides times the sine of the angle between them. Perfect. Okay, now we'll just multiply straight across. Chelsea, what's half of 8? And then 4 times 6? 24. Good. Okay, if you're not sure what the sine of 30 is, you can do that on your calculator. But when you type in sine 30, you get 1/2. Okay, that one comes out nice. The only thing you'd want to double check, make sure you are in degrees before you type it in. Okay, but if you want, go ahead, double check it. Okay, so my final answer here would be what? 12. Yeah, this didn't give me units. Just said 8 and 6. So just say 12 square units. Okay, we'll do some that have feet or inches, and we'll label it accordingly. Okay, any questions on that? All right, let's take a look at this one. Okay, find the area. This time they did it as a diagram. Did they give me the correct information to find what I want to find? Yeah, and even if you get rid of that stuff, it doesn't matter. You don't need to know what version of the formula you're using. You need to know this general idea. Half the product of two sides times the sine of the angle between. Okay, somebody else think they can give me my formula to find the area here? What's my formula to find the area here?
A equals 1/2 times 3 times 4
Yep, 1/2. We got 3 times 4.
sine 30.
Sine 30. Okay. So now just multiply everything out left to right. Half of 3 gives me 1.5. 1.5 times 4 is 6. Okay. Or you can think of it as 3 times 4 is 12. And then half of 12 is 6. It doesn't matter how you think of it. Sine 30. And what did I say earlier? The sine of 30 is a half. So what's half of 6? 3. And what about my units on this one? Inches squared. Okay. Any questions on that one? All right, so not too bad. All right, this one, we'll just do it out only because it doesn't come out to a nice answer. Okay, so this one, let's round to 2 decimal places. On a test, I'll always make sure that I tell you if you need to round, where to round to. So A equals, Cooper, can you start me off with this one?
1/2, 2 times 5.
Yeah. So 1/2, 2 times 5. Anybody else finish it up? What's the last thing? Times sine 20. All right, so if we do that out, Justin, what's half of 2 times 5?
5.
Yep, 2 times 5 is 10. Take half of it. So you have 5 sine 20. Just type that in and see what you get. Okay, so there's the sine of 20 times 5. I did check I'm in degrees. If I wasn't, I would have fixed that. 1.71. Okay, did they give me a unit on this problem? No. So just put square units. All right, so those kind of problems aren't too bad. Everything you need is directly given to you. We can also find the area of a triangle, even if all we know is the 3 sides. Okay, anybody explain to me how we would find the area of this triangle using the formula we did before? And maybe first question, can I use the formula with what I know right now? Brandon?
No.
No. Somebody else tell me why not. I don't have what? Yeah, I don't have an angle. Okay. Does it matter what angle I have? No. I could have any one of these 3 angles, but I need one of them. Okay. When we know all 3 sides in a triangle, what's the way we learn to find one of the angles? We've talked about this earlier.
Law of cosines.
Law of cosines, yeah. Okay, so if we use the law of cosines, we can set it up however we want to find one of the angles. Right? Let's let's try to find this one. Right, so we always start out with the side that's across from it. Okay, so I'll start you off. We get 5 squared equals. Okay. Somebody tell me the other two things I'm going to put on that side. If you want, think of this side as C, think of this side as A, think of that side as B. It doesn't matter, really. Yeah? 8 squared, 4 squared, minus, then it's 2 times what times what? 2 times 4 times cosine of that angle, okay, whatever we want to call it. Since it's across from C, let's call it gamma. Okay, so now let's go through and see what we get. Okay, 5 squared is how much? 25. Okay, 8 squared, that's 64. 4 squared is 16. What's 64 plus 16? 80. Minus 2 times 8 is 16. What's 16 times 4? 64. Cosine gamma. Okay, now this part we just want to be careful. What do you do next? Think about if it was 25 equals 80 minus 64, x. 64 is multiplied by something you don't know. Yep.
Minus the 80 first.
Yep. You're going to bring that 80 to the other side. You can't do 80 minus 64 because of that cosine gamma. Okay, so that's gone. 25 minus 80 is negative 55. Okay, and then one more step and I'll have gamma, cosine gamma by itself. Okay, how do I get that negative 64 on the other side? Yeah?
Add 64.
Well, think if you had something like this.
Divide 64.
Yeah, you have to divide, right? Since this is negative 64 times x, you're going to divide each side by negative 64. Okay, we are going to get to inverse, but not yet. But yes. Yep. Okay, so divide by negative 64. Okay, 64 is gone, negative's gone, and those negatives are gone. All right, so George is our expert on inverse. You are now. So George, what do we do to get rid of cosine? Inverse cosine. And if you do it on the right, it gets rid of it. So now we type that in, and then we'll know gamma. And once we have our angle, this is super easy. Okay, that's the fast part. This is the part that took a while. All right, so let's do inverse cosine. 55 over 64. Okay, now I can do it in either degrees or radians. For this problem, I prefer degrees. So let's do it that way. And our angle is 30.754. Okay, so this angle is 30.754. Okay, now we've got the 3 things we need to find the area. Okay, so 1/2. Okay, what's going to come next? So it's going to be area is 1/2. What 2 sides do I want to use here? George?
A and B.
Yeah, I got to use A and B because that's the one I know the angle between. Okay, if I had found a different angle, I could have used different sides. Okay, but I got to use 8 times 4 times, what's the last part, George?
Times the cosine of 30, 47, 5, 4.
Times the what?
Isn't it cosine 30.754?
Is that our function we use when we find the area of a triangle? Is it cosine? Sine. Yep. So remember, we've been using sine. Right? If you use cosine, we get all that work. That last part, just pressing the wrong button is going to mess us up. All right. So sine 30.754. Okay. I'll just type it all in. See what we get. This part I can simplify before I do it. 8 times 4 is 32. What's half of 32? 16. Good. Okay. Now we got to use our calculator. But we know the sine of 30 is pretty close to what number? A half. So this answer is going to be pretty close to 8. Okay, a little bit bigger than 8. So 16 times sine 30.754. We get about, let's just say 8.18. Okay, did they give me units? Yep. What should be my label on this? Feet squared. Okay, so a little bit more work when you got all the sides, because you got to use law of cosines, and you got to find an angle. Okay, but you could have found any angle you wanted. Okay. Any questions on that one? Okay, I want you to remember that number. Okay, and this example. Okay, something's going to come back with this in a little bit. Well, it's fine to do it that way. It worked. The answer we just get is correct. Worked perfect. But if you know all 3 sides, there's an easier way to do this. You don't have to go through the law of cosines. The reason I had you go through it is because now you can appreciate the beauty of Herons Formula. So Herons Formula is going to take all that work we just had to do with law of cosines. It makes it go away, and we're going to get the same answer. Right? We're not going to go through the proof of where this comes from. The proof is pretty long. Okay, it's in your book. We're just going to use the formula. So if you know all 3 sides, we can use this formula. It's the square root of s times s minus every side. S minus a, s minus b, s minus c. Right? So we've seen A, B, and C before. We know those are our sides. We haven't seen S. Anybody have a guess what that stands for? This is hard to guess. It has something to do with the sides. It has something to do with all the sides added up. What do you call that when you add up all the sides? That's the perimeter. The only thing here is we don't need the perimeter. We need half the perimeter. Okay, S is called the semi-perimeter. To find the perimeter, add up all the sides. To get the semi-perimeter, take half of it. Again, why? Well, that's the proof. We're not going to go through the proof of this. It's pretty involved. But it is a pretty nice formula. It's pretty simple. We just plug into this, and automatically it does law of cosines. We don't even need to think about it. So we'll come back to that triangle problem we just did that probably took us like 6 or 7 minutes to go through. This makes it so we can probably do it in under a minute. It's a lot faster. And this is called Herons Formula. The other formula I showed you doesn't have a name. The 1/2 product of the 2 sides, there's no special name there. Okay. Does everybody have the formula? All right. So now let's try to find the area of this triangle. Okay, my sides are 4, 5, and 7. Right? Before I can even use Herons Formula, what do I have to find first?
The semi-perimeter.
Yeah, I got to find the semi-perimeter. So let's get that first. So it's 1/2, and then add up all the sides. Okay, so what's my semi-perimeter here?
8,
How much?
8.
Yeah, it comes out to 8. Right, so now fill A, B, C, and S into that formula. And that's it. So the arithmetic is very straightforward, nowhere near as complicated as doing something with law of cosines. So we've got area equals. Okay, what's the first thing that I write down? Yep, my semi-perimeter, which is 8. And then I have 3 sets of parentheses. Okay, what's the first one? 8 minus 4. That's 8. That's S minus A. What's the second one?
8 minus 5.
8 minus 5. And the third one? 8 minus 7. So it doesn't even really matter which side is A, B, and C, because you've got to do S minus every one of them. Okay? So we have 8 times 8 minus 4. 8 minus 5. 3. 8 minus 7. 1. 8 times 4 is 32. Tripled. What's 32 times 3? 96. So that's our area. So square root of 96. Okay, which is about, if we round to 2 decimal places, that'd be 9.80. Okay, let's go up and look at our units. Nope, no units this time. So just put 9.80 square units. Okay, any question on that one? All right, so now I want to do this one. What do you notice about this one? Same triangle as what?
Oh, we did 2 problems.
No, it's the one we just did with 8, 5, and 4. So let's find the area with Herons formula and see, first of all, how much less work it is. We're going to avoid this whole part. And let's see if we get 8.18. Okay, so let's try it. First thing I want to do is find my semi-perimeter. Okay, so take a look at that. Add those up in your head. 8 plus 4 plus 5. And take half of it. Hey, what's my semi-perimeter here? 8.5. Yep. All right. Anyone think they can tell me the whole formula to find the area? Or maybe even just part of it if you're not sure the whole thing. Yep.
It would just be 8.5 minus 8.
So 8.5, yep.
And then,
All right, so we get the 8.5. George, can you just give me one part?
Yeah, 8.5 minus 8.
8.5 minus 8. That's good. What comes next? 8.5 minus 5. And last? 8.5 minus 4. 8.5. Now, how did you know which sides were A, B, and C? Because I said it was S minus A, S minus B, S minus C. It doesn't matter. Okay? You got to do 8.5 minus every side. Okay? All right, so this one, I think we can do the subtraction, but then the multiplication, we're probably going to need a calculator. So we've got 8.5. Okay. What's 8.5 take away 8? 0.5. How about 8.5 take away 5? 3.5. And the last one? 4.5. All right, now I think it's a good time to use our calculator. Okay, so I've got 8.5 times 0.5 times 3.5 times 4.5. I got 66.9375. That's not the same area as the last problem.
Just square root.
I still have to square root it, yeah. All right, so what was it 669375? And now we're hoping we get, was it about 8.18?
Yeah.
And that's exactly what we got. Okay, 8.18. And remember, units were square feet. Okay, so whether you want to use Herons Formula, or if this formula, you know what, you say I don't want to have to remember another formula, fine. Then just use the law of cosines, find an angle, and do it that way. But you can do it either way. Okay, any questions on that? All right, what are some special kind of triangles we have besides a right triangle? Okay, we could have an acute triangle, yeah. Isosceles, okay, we're getting on the right track, I'm thinking. Scalene and equilateral. Okay, equilateral, that's really a special one. Because what happens there? All the sides are the same. So we could use Herons Formula, okay, to find the area of a triangle that's equilateral, but there's a lot of repeat in there. Okay, if you're doing the same thing 3 times, there's got to be a shorter version of that formula that would work just for equilateral triangles. So that's the last formula we're going to come up with. Okay, a formula that will find the area of just an equilateral triangle, and it's going to be even faster than Herons Formula. Okay, by the time we're done. All right, so for now I have just a generic equilateral triangle. And how could I label these sides if I don't know them? Keep in mind it's equilateral. Yeah, George? So all these sides are different lengths? Because you picked 3 different things.
You just do the same.
Yeah, you could make them all X, sure. Whatever you pick, make them all the same thing. So all 3 sides are the same. Which means when I fill in Herons Formula, quite a bit of stuff here is going to simplify. All right? What's the perimeter if you add up this side plus that side plus that side? Add up all 3 sides. X, what is it? Yeah, x times 3, or we could just say this is 1x, 1x, 1x. That's 3x. And what do you have to do with the to get the semi-perimeter? That's the full perimeter. Take half of it. Let's just take half of it. Okay, so the semi-perimeter is 1.5x. Or you can just, I'll leave it as a fraction. 3/2 x. Okay, now let's fill everything in, simplify it, and see what happens. Okay, when we're done, we actually end up with a pretty nice formula. A lot smaller than Herons Formula. Okay, so here's S. 3/2 x. Okay, what comes next? Remember, whatever comes next is going to be repeated 3 times.
3/2 x minus x.
Semi-perimeter minus my first side. Semi-perimeter minus my second side. And semi-perimeter minus my third side. Now, what number is in front of all these x's that they don't have any numbers right now? Yeah, if you want to put in 1, 1, and 1, you can. All right, so this part for now stays the same. 3/2 x. What's 1.5 x take away x? Well, yeah, think of it as 1.5x take away 1x. That's a 1/2 x. Okay, what about the second one? And the third one? 1/2 x. So it's a 1/2 x repeated 3 times. So 1/2 x times 1/2 x times a 1/2 x. So this says 3/2 times x times a 1/2 times x times a half times x times a half times x. When I multiply, does the order I multiply things in matter? Like if I did 2 times 5 times 6 or 6 times 5 times 2, does it make a difference? No. So what I'm going to do to simplify this, just group all my numbers together. 3 halves times a half times a half times a half. And then I have x times x times x times x. That's x to what power? To the 4th. Okay, and don't forget what x is. What was x originally? It's one of the sides. Okay, it's the length of the side. Okay, now to multiply these fractions, just go straight across. What's 3 times 1 times 1 times 1? 3. And what's 2 times 2?
4.
Times 2?
8.
Times 2 again.
16.
16. Right. And our last step here, we can take the square root of all 3 of these things separate. So it's square root 3, square root 16, and square root of x to the 4th. Okay. That's how you take the square root of all this stuff right here. Do each one separate. Does the square root of 3 come out to a nice answer? No, so we'll just leave that. How about the square root of 16? Yep, that comes out nice. And now try to think, what 2 numbers can I multiply together? What times what gives me x to the 4th? X to the 2nd times x to the 2nd. So that's the square root of x to the 4th. And that's the formula for the area of an equilateral triangle. That's it. So now all we have to do is, if we know a side, fill it in for x. You don't even have to use Herons Formula. This is even shorter. Okay? So this is the area of an equilateral triangle. But using Herons Formula, hopefully you can see where this comes from. It's not just random numbers. They all came from part of the Herons Formula. And Herons Formula comes from the law of cosines. What do you think a disadvantage is, though, of this formula compared to the other 2 I taught you earlier? I don't think this one is as useful. How come?
It's so specific to an equilateral triangle.
Right, it's very specific to a type of triangle. You can only use this on an equilateral triangle. If you have any other kind of triangle, you can't use it. Okay. All right, so a problem you might see. Let's see, what was our last example? 5. Does everybody have the formula? All right. So find the area of an equilateral triangle with side lengths of, just pick any number, 8. Okay, so it's an equilateral triangle with 8, 8, and 8. Okay, so 3 options, the way you can do this. First option, draw the equilateral triangle. You could think about what the angles would have to be. You could use law of cosines to find one. Or if you're clever, you already know, what are the angles in an equilateral triangle?
60.
They're all 60. So actually, you wouldn't have to use law of cosines. And now you could go back and use the first formula that we learned. Okay? Probably not the best option. Second option would be just plug this into Herons Formula. 8, 8, and 8. You've got to go through all the work and do a lot of repeated calculations. Okay? Again, probably not the best option. Best option for this one, just use the formula for the area of an equilateral triangle. X squared, square root of 3 over 4. X squared, square root of 3 over 4. That's it. Okay. It's the fastest way to do that problem. So we get 8 times 8 times square root of 3 and divide by 4. It's about 27.71. Square roots. All right, so any questions on area of a triangle? All right, so the very last thing we're going to take a look at is it's kind of like a preview of what you're going to see Tuesday, Wednesday, and Thursday. Okay, I just want you to see kind of the idea. Okay, but we're not going to spend more than 5 minutes on it. Okay, but anything else on area of a triangle? All right, so totally different thing. It's a bonus preview. So for Tuesday, Wednesday, Thursday, we're going to look at what are called trig identities. Somebody remind me, what are my 3 basic trig functions? Yeah, sine, cosine, and tangent. Okay, and the easiest way to show you what a trig identity is just give you an example and show you that it works on the calculator. So back when we did unit circle trig, okay, we had a point, we had to draw a triangle. Okay, we found the coordinates of that point. People vaguely remember this kind of stuff. Well, each one of these was equal to a letter. Anybody remember what letter sine equaled? It's not x. Y, yep. Sine was y. Cosine? Yep, cosine was x. And then tangent was, it was y divided by x. Okay. What did you guys just tell me earlier y was? What's y equal to? Y is sine. And what about x? Cosine. So what does that mean about tangent? What does tangent really equal? Tangent is really sine divided by cosine. Tangent is a simpler way of saying sine over cosine. Somebody give me an angle, any number, except 90.
75.
70 what?
75.
75. All right. So I'm going to take the tangent of 75, make sure I'm in degrees. That's what I get. Now I'm going to take the sine of 75. I'm going to divide by the cosine of 75, and I get exactly the same thing. All right. So whether you take tangent or you do sine divided by cosine, it's exactly the same thing. All right. So I could say to you something like, I want you to tell me what tangent times sine equals. Well, actually, would that be, let's do this. Tangent times cosine. Okay, I want to know what that equals. Right? Because this is kind of complicated. It's got 2 trig expressions. They're multiplied. This can simplify. Well, what did we just say tangent was? Yeah. Tangent is sine over cosine. And if cosine doesn't have a denominator, you can always just think of it as being over 1. Well, what happens there?
Is it the same for inverses too?
No.
No?
No, inverses are different. Yeah, we won't be doing anything with inverses the rest of the week. No. But that's a good question. What happens here? Yeah, if you have the same thing in the bottom and the top, just like a regular fraction with numbers, they cancel out, and you're left with just sine. So in other words, if you take tangent times cosine, the answer is just sine. That's a trig identity. And that's the kind of stuff we'll spend Tuesday, Wednesday, and Thursday on. There's as many as you want. You can make up millions of identities. Some get very hard. This would be considered a pretty easy one. It's one step. Okay, we'll look at ones in this class that are kind of medium to easy. Okay, we don't get into anything that's too hard. But I think if you look in the back of your book, okay, right on the inside back cover, there's a page, I don't know if you guys can see it, it says trigonometric identities, right? And there's a bunch of them listed. Okay, some books have 20 pages of identities. Because an identity usually isn't something you memorize. It's something that you know the basic ones. Okay, there's like 12 basic ones. This is one of them, tangent equals sine over cosine. But for complicated ones, you just look them up. Okay? Because usually you use identities to do other things. Okay? Doing this just for the fun of it isn't exactly why we do them. Usually this is part of a calculus problem. The difference in this class, you're never going to see the calculus side of this problem. You're going to just see the trig identity part. Okay? Right. Any question on that? How you doing, Andy? You good? All right. All right. So the homework tonight is just on the area of the triangle. No identities yet. Okay. Try 6 to 16. Okay, just the evens. 20, 22, and 33. And here's a hint for number 33. Okay, they want you to find this region in blue. Find the area of it. Well, the way you have to do it is find the area of this region in red, which is called a sector. We did that second day of class. Find the area of the sector. Find the area of this triangle. This is what we did today. And subtract them. And you'll be left with this area in blue. Okay, so that's a hint for number 33.